This lesson will be on factorising expressions. Now, when we're factorising, what we're doing is actually writing an expression as a product of its factors. In many ways, factorising is actually just the opposite process of expanding an expression. So let's jump straight into an example. Factorise 20a squared plus 30a. Now, the first thing we want to do when we're factorising is, if possible, take out a highest common factor. So in these two terms here, both terms have an a and both terms have a common factor of 10 as well. So we can take out a highest common factor of 10a. And then in brackets, we need to think to ourselves, what do I need to multiply 10a by to give me 20a squared? Well, we need to multiply it by 2a. Likewise, what do I need to multiply 10a by to give me 30a? I need to multiply it by 3. So as you can see, it's almost the opposite process of expanding. When we're expanding, we're trying to get rid of the brackets. When we're factorising, we're trying to put in brackets. And often we can do this by taking out the highest common factor. So if you want to check your answer, we can go back and expand it in this factorised form we've got here. So 10a times 2a gives us 20a squared. 10a plus 3 gives us 30a. Let's jump into another question. Factorise 9a squared minus 4b squared. Now, this expression that we've got here is actually what's called a difference of two squares, or sometimes a difference of perfect squares. And in order to factorize it, we can use the identity that difference of perfect squares, a squared minus b squared equals a plus b, a minus b. That identity for us here is going to be very helpful. So 9a squared, if we use this identity of the difference of two squares, we can make this 3a all squared minus, this will become 2b all squared. From there, we can get 3a minus 2b, 3a plus 2b. Now, if you want to check this, and check this identity actually works, go back and expand it. So let's expand it here. 3a times 3a will give us 9a squared. 3a times 2b will give us 6ab. Minus 2b times 3a will give us minus 6ab. So those will cancel, and then minus 2b times 2b will give us minus 4b squared. So that's how that identity works. Let's have a look at another one that's a little bit more difficult. Question 3. Factorise 12y squared minus 1200. Now, remember, the first thing we want to do, if possible, when factorising, is to take out the highest common factor. If you can do that, then that is always your first step. Here, whilst you might look at this and think straight away difference of two squares, what we actually want to do is take out the common factor of 12. So we'll take out the 12, get y squared minus 100, and now we can use the identity of the difference of two squares. So that will become 12, and then we'll have y minus 10, y plus 10. Let's have a look at another question. Sometimes using this identity of a difference of two squares, we actually need to use surds. So let's have a look at a question where we need to use surds. X squared minus 24. If we want to factorize x squared minus 24, you'll notice that 24 here, it's not a square number. So it's not as simple as just finding the square root of 24 because it's not, 24 isn't a square number. So what we can do though is write it as x squared minus root 24 squared. And so we've created a difference of two squares here, and that will become x plus root 24 x minus root 24. Now we haven't quite finished because the square root of 24 can be simplified using surds. So root 24 will become 2 root 6 and x minus 2 root 6. Let's have a look at another one. Question 5. Factorize x minus 1 squared minus 5. Now, this one's again involves another step. Firstly, 5 is not a square number, so we're most likely going to have to use surds here. Let's start by writing this out as x minus 1 squared minus root 5 squared so that we can see the identity there of it being a difference of two squares. From here, we can write it out as x minus 1 minus root 5, x minus 1 plus root 5. So you need to be careful. This x minus 1 just stays as is. That term there, that expression x minus 1 is squared. So in both brackets, it just stays as x minus 1. Alrighty, let's have a look at one final question. Factorize x squared minus x plus ax minus a. Now, when we have an expression with 4 terms, if possible, we want to factorize this expression by pairing two of the terms together. So why don't I pair these first two together here and then pair these second two terms together. If we factorize the first pair, we've got a common factor of x, so we can take that out and in brackets we'll get x minus 1. If we factorize this second pair here, we've got a common factor of a, and then in brackets we'll get x minus 1. Now what you'll notice is that both terms have a common factor of x minus 1 now. X minus 1 and x minus 1. So we can now take out that common factor and then in the next bracket we'll have x, that first x out the front, and then this a out the front of the second part of the expression. Now, it's important to point out that these two brackets here, for factorizing by grouping, these two brackets always have to be the same. They have to be matching because that then becomes the common factor that you're taking out. So if these two components in the brackets aren't matching, then you haven't done something quite right. So just make sure those are always matching. And then the second bracket will always have what's outside of each of the two brackets. So here it was x plus a.